Hi all, today we are going to discuss about the deletion in a binary search tree. So deletion in binary search tree, last class we discussed about in creation of a binary search tree, how to insert element in a binary search tree, all those things that we discussed in the last class. So today I am taking this diagram, this binary search tree diagram as an example for deleting the element. So here we have three cases of deletion. First one, deletion of a leaf node. Second one, deletion of a node with one child. Third one, deletion of a node with two children. The first case, the deletion of a leaf node. It's very simple. If you are deleting a particular node, consider the leaf node here is 20. 20 is a leaf node, and after the deletion of 20, what are the changes that we have to make here is its parent node's right address field, that is this part, has to be deleted, and correspondingly all the remaining updations like deletion, making this particular node make the node as a free node, and so that you can delete. Okay, so this one also get deleted. Okay, so this is a case. This is a case of a first one, the deletion of a node, deletion of a leaf node. Second one, the deletion of a node with one child. So in this case here, here we have 10. Consider 10 is a node that we are choosing here for deletion. In this case, if you are deleting 10, so what are the operations that we have to make? Here its parent node is 25. Its left address field is 300. So that has to be replaced with the right address field or a left address field, because I am choosing the second option, deletion of a node with one child. Here this is one of the example. 10 is a node with one child. At the same time 90 is a node with one child. Here 10's left address field is null, but right address field is having an element. That means in the case of a 90, left address field is not empty, not null. That means its left address field having element. So what we have to do is, once we identified the element for deletion, so we identified that 10 is going to get deleted. So what we have to do, verify whether this is a leaf node. Okay, first case, verify whether this is a leaf node. So after the verification, we identified that it is not a leaf node, and next step is to identify whether the node is having only one child. Okay, in this case, this left address field is null. So from that, we identified that this is not a leaf node, and this is having only one child. So from this identification, we confirm that this right address field is not empty. So what we have to do, we have to collect the address from its right address field and place it here, so that the further updations can be performed. So what we did is, we deleted this particular node, and instead of that, we place this particular node here, so that 400 is placed here and this node is available. Okay, so this is a case of a deletion of a node with one child. So first step is to identify whether where the node is located. So while deleting a particular node, first step is to collect the node from the user. We will collect the node from the user for deletion, identify that particular node by searching. After identification, what we will do is, we will verify whether the node is a leaf node. So if the node is a leaf node, then we will do the first case of deletion. If the case is false, if not a leaf node, then we will verify whether the node is having one child. Yes, if this node is having one child, then do the updation as it is. The third case is deletion of a node with two children. So I am taking this one as an example, 35. So here two options we have. Either you can choose the largest element from its left subtree. In this case, I am deleting 35. So 35 is having a left subtree and a right subtree. Left subtree elements are 25, 10, 30, 15 and 20. Right subtree elements are 45, 40, 90 and 55. So if I am deleting 35 from this particular tree, you have two options, two answers you may have. Either you can choose the largest element from its left subtree, or you can choose smallest element from its right subtree. Okay, in this case, the smallest element from its left subtree is 30. Largest element from its left subtree is 30. How will you identify that? So the option is you can travel, you can choose the in-order traversal of for this particular left subtree. So what's the in-order traversal of this left subtree? 10, 15, 20, 25 and 30. The largest element will always reside at the last position. So what we will do, we will take 30 instead of that 35, 30, and this node will be deleted. So that is one case of one answer in the case of a deletion. So we identified that 35 is located in this particular tree, and 35 is having two children. Left child is there and the right child is there. So you have two options. One option is choosing the largest element from the left subtree, or you can choose the smallest element from the right subtree. So in this case, what's the smallest element from this right subtree? So perform this. You can choose any of the option. Either you can choose the largest element from the left subtree, or you can choose the smallest element from the right subtree. So right subtree elements are 40, 45, 55 and 90. Perform the in-order traversal on this particular tree. So 40, 45, then 55, 90. This is the in-order traversal of this particular right subtree. So what you have to do is you have to choose the smallest element. Smallest element always resides at the first position. So what you can do is you can place 40 here. You can choose 40 from here and place it in the position 40. So these are the two options in the case of deletion of a node with two children. Thank you. If you have any doubt, we will discuss. Thank you.